the Unacademy Plus subscription or Iconic will be having this batch, which is JRF Educators batch. Various batches I am announcing today, not only paper 1 and commerce and remaining other batches also, which is available from the 3rd of July. These batches are going to start. Especially me and Niharika ma'am will be starting paper 1 complete batch as well as paper 2 commerce complete batch course. So at Unacademy Plus as well as Iconic subscription plans. You can look at UGC NET paper 1 complete schedule, which is titled as an Ascent batch. This year for the December 2023 Ascent batch course on paper 1 complete all 10 units. This is a final schedule that you can see. So this is a schedule for commerce, all the 10 units in a detailed way, and as per the schedule which is going to be announced by the NTA for the December examination, once we complete all the theory courses, we will align with the next previous year questions on year wise or unit wise. Later revision courses will be announced according to the schedule of the NTA. So this is a detailed plan of the entire both papers 10 units. All these batch courses will be available at Unacademy Plus subscription or Unacademy Iconic subscription. Either of the subscription you can take it for the benefit of you. There is an offer which is announced by Unacademy. 25% discount if you take the subscription before the June 30. So 4,000 minus with a 25% off means 4,000 was deducted as a discount by applying my code Shiva Live, SHIVA LIV. I'll be putting all these batch links in the description also. Properties. Property number 1 are the characteristics of a regression. Characteristics of a regression. First characteristic is that the property is that regression is ranging from -1 to +1, correct? -1 to +1 will be there. This one is good, okay. -1 to +1. It can be a +1 or equal to or else more than -1 also. It can be, but till the -1 only it will be there. -1 to +1 it will be there. Next, second is that correlation. Most important property is this one only. Correlation coefficient is an independent of a change as well as independent change of a scale also. Independent of a change of origin as well as scale. Whereas regression is an wait. Very sorry. I was seeing the slide of the correlation. That's why I got a doubt already. Here regression coefficient and correlation coefficient have same sign, right? That is the first property. And coefficient of correlation is an geometric mean of the regression coefficient. This I have studied, this I have explained in there also, and here also I am explaining. In the correlation property also this is there. That is under root of Bxy into Byx, which is R equal to. And third property is like If one of the regression coefficient is greater than the unity, other must be less than the unity. If one regression coefficient is greater than the unity, then other should be less than unity. If one is greater than unity, greater than 1 means other must be less than 1, because it must not be more than 2. Next is that fourth property, which is most important property, the regression, which I am writing in a different color also. Yes, if one is greater than 1, other must be less than 1. The regression coefficient are independent of change, but independent of change of origin. This is but dependent of scale, right? Independent of the change of origin but dependent of the scale. Scale is indicating what, and this origin is indicating. Origin is nothing but a plus or minus only, addition and subtraction, whereas scale is indicating multiplication as well as division. Multiplication. So multiplication and division is impacting the regression, whereas it won't impact on the correlation. Regression coefficient is affected by the multiplication and division, whereas regression coefficient is not affected by the addition and subtraction. That's what the meaning of the independent of origin and dependent of the scale. And next, the fifth point is that origin plus minus multiplication and division are scale. Arithmetic mean of the both of the coefficient of correlation is equal to greater than the coefficient of correlation. Look at arithmetic means both of the regression coefficient arithmetic mean byx plus bxy. This is the divided by 2. This is the arithmetic mean of the regression coefficient. This is more than or equal to r only. Means arithmetic mean of the both regression coefficient of correlation is equal to or greater than the coefficient of correlation only. This is a coefficient of correlation, right? Coefficient of correlation. Arithmetic mean of the regression coefficient are more than or equal to. It must not be less than the correlation coefficient. It will be equal to the correlation coefficient or more than the correlation coefficient, but it is not less than the correlation coefficient, right? Next, the sixth property is that these are the 5 main properties by. That's it actually. Now if I can discuss the some more, regression coefficient in terms of the deviation. Regression coefficient in terms of the deviation. In terms of a deviation of x and y, values from the respective mean. I hope handwriting is properly visible to you and understandable to you. I am not troubling you much in this session because just only regression properties are remaining are. I can't able to make the properties in the slide, don't have a time, but I will give you in the PDF form for sure. So here regression coefficient in terms of a deviation, wise. In terms of a deviation of x and y value from the respective mean is that byx. Most important, very carefully see. Summation of xy divided by summation x square. So the x which is coming later will be n square in the denominator. In the same way, bx and y is equal to summation xy divided by summation y square. So same way here also, which is later and denominator will come over. Now you tell me whether x is in the first case byx, y is dependent on the x, means x is an independent variable. Independent variable comes in the denominator always. So that is summation xy divided by summation x square, summation xy divided by summation y square. Right? This formula as it is they have copy pasted. This formula they have as it is copy pasted, and they will ask you in the math the following, or they can put you in the questioning form also. They can put you the problematic question also. Next is that regression coefficient. This is in terms of the deviation. Now I am going to tell you in terms of the standard deviation of the x and standard deviation of the y. Standard deviation of the x and standard deviation of the y. Same regression coefficient in terms of a r comma standard deviation, which is denoted by this one sigma, and standard deviation of x, standard deviation of y. That is, standard deviation is nothing but standard deviation of x and standard deviation of y. Independent variable will be the denominator in the deviations case. Whereas now in terms of the r as well as standard deviation, if you look at r is equal to, no, not visible, I think. Okay. R is equal to covariance of x comma y. They will give in the question if they wanted to ask the question in this way. Covariance of x divided by standard deviation x into standard deviation y. Right? Based on this question, based on this formula, now if you wanted to go b y on x, b x on y, b y on x and b x on y. B y on x is equal to r into sigma x divided by sigma y. B1 sigma y divided by sigma x, na ulta. Sigma y divided by sigma x, because independent variable in the denominator. Now r into sigma x divided by sigma y. Sigma x into sigma x divided by sigma y. R into. So this is regression coefficient in terms of a standard deviation, and r is involved. But here we know very well, like bxy into byx. Byx is equal to r square, which is an regression square, or else correlation square. Sorry, these are correlation coefficient of determination, we can say. Now based on that formula, we can also write in this way. What is the bxy formula? Bxy formula is that r into sigma y divided by sigma x multiplied by r into sigma x divided by sigma y. Right? Like this we can write. Now x and x cancel, y and y cancel. What is left over? R square. We got it now, coefficient of determination, or the correlation we got it. If not coefficient of relation, if you convert that into a root, that will become correlation coefficient. Simple, it's a derivation from then and there only. It's a derivation. Now you know r is equal to under root of bxy into byx. How the derivation came? This is how the derivation came over there. The property number 2 which we discussed in the correlation as regression. The property number 2 derivation is in this way. That's why we are saying correlation coefficient is equal to under root of the regression coefficient of both. Is that clear? Now with this I am putting an end to correlation. Almost I have covered all the important points from the examination perspective. None of the point is ignored. But there is a one slight point I wanted to cover over here, which I have given in the first slide now. Over here, you can just look into these statements which are mentioned over here. Clear? Done. Thank you. I hope everybody hitting the like button. Those who didn't. One big formula is there by which we have already. These are the regression lines. Correct now, regression lines. In this y is equal to a plus bx and x is equal to a plus by is there. That's two formulas which we learned. But I can write this y is equal to a plus bx formula as y minus y bar equal to byx into x minus x bar. This is for the byx formula. Alternative formula for the same linear equation. Y minus y bar is equal to byx into x minus x bar. Whereas alternative formula for this is x minus x bar equal to bx on y multiplied by y minus y bar. Sometimes they may give a alternative formulas to confuse you. So the same derivation will be comes over here. Either this can be a c plus dy, this can be a c plus dy or a plus bx. This can also be written as an c plus dy. In such a case, a and c are called as an constant intercept, and b and d are called as an independent variables, and y and x are called as an dependent variables. Either way you can write it. That's an alternative way of writing a formula simply. Now a final one which I just wanted to give you the formula is that there is a one final formula. These are all formulas only, but questioning of a problematic application will be very much less, but the properties they can put you under the assertion, reasoning, statement as the following. It can be of anything. Byx formula, bxy formula, again big formula it is. Number of variables into summation x y minus summation x into summation y. Okay, this is divided by n into summation x square minus summation x whole square. Right, this is the formula. Remember this one, n into summation xy minus summation x into summation y. Now this is x now over here, independent variable x square, which independent variable always will comes in the denominator only. Remember that blind rule. Now how can I write this one? N into same numerator xy minus sigma x summation y whole divided by n into summation y square. This is of x square now. This is of y square minus summation. What will come? Can you please tell? What will come? Summation y square will come, because this is independent variable. Y is an independent variable over here. That's it, bye. This is the end of the regression. Now we can move like anything towards a next. Now no book is required, no slides only. We can move ahead. Everybody understood with this? Let me recap once. Let me go to the first slide so that you can understand in a very easier manner. It is denoted by B. Yes, sir, denoted by B. And if two variables x and y are the two values of regression coefficients obtained, and one will be independent, one will be dependent value. We consider y as an independent and x as a dependent usually. So regression coefficient is denoted by byx and bxy. Both regression coefficient must be having a same or a positive, either a negative. In the same way it has to be there. If one regression coefficient is greater than the unity, other will be with less than the unity. And the geometric mean between the two regression coefficient is equal to correlation coefficient, that is under root of the bxy into byx. And the arithmetic mean of the both regression coefficient is equal to, greater than or equal to only, but it must not be less than to correlation. This is what discussed so far. And covariance formula, two formulas are there: summation x minus x bar into y minus y bar divided by n, and or else summation xy divided by n minus summation x divided by n into summation y divided by n. After that, geometric mean, and it must be having a same sign, all these and the regression coefficient is independent of change of origin, not of a scale, because it is dependent on the scale. That is, dependent on the scale is nothing but it is impacted by the multiplication and division. It is not impacted by the subtraction and addition. Next, covariance in terms of the deviation, so regression coefficient in terms of a deviation x and y, that is byx is equal to summation xy divided by x square, summation x square. Bxy is equal to summation xy divided by summation y square. And in terms of a standard deviation, covariance of xy divided by standard deviation x into standard deviation y. After that, byx is equal to r into standard deviation y by x, and bxy r into standard deviation x by y. Then if you get the like total derivation of the under root of bxy, then please multiply this both, you will get r square, which is under root of the r equal to under root of the bxy into byx. This is the end of the regression. I hope I am clear. Now let's see the difference between the both by. Correlation is a statistical correlation, means the association it will be giving you. Whereas regression is an independent and dependent, means a cause and effect will be revealed by the regression analysis. It is to represent the linear relationship between the two variables, means association. Here, to fit a best line, whether it is one variable on the basis of other variable, what will be the best line? And no difference between the dependent and independent variable. There is no dependent because both are independent over there. Independent of origin, independent of a scale. Whereas here, both independent and dependent variable are different, and it is independent of origin but dependent on the scale. So here indicates to what extent to which two variables are moved together in the same way. Like move together is nothing but that is an association established. Whereas impact of a unit change in one variable, how it is going to change in the other variable, whether it is going in the same direction, whether it is going the opposite direction, that's an regression. And finding a numerical value expressing a relationship is a correlation. Whereas to estimating the value of a unknown variable identification, we know with a one variable, we are trying to identify the unknown variable by the help of a regression. And here limited application, whereas this is a wider application will be there. This is a clear-cut difference. Now final summary note I am giving till now, whatever the discussion so far, whether it is a mean, median, mode, range, mean deviation, standard deviation, correlation coefficient, regression coefficient. Look at everything, only correlation coefficient, regression coefficient slightly differs. Mean, median, mode are three measures of a central tendency. These are impacted by the origin, means plus as well as minus. Because of the plus sign minus, it will be impacted. Whereas multiplication and division also, it is dependent on the scale also. Multiplication, division is also impacting on the measures of central tendency, right? Measures of central tendency impacted by the origin as well as the scale. Next, range is independent of origin. Range, mean deviation, standard deviation. Range, mean deviation, standard deviation are not impacted by the addition and subtraction, but impacted by the multiplication and division. That is plus independent of origin but dependent of a scale. Independent of origin but dependent of a scale. That is range, mean deviation, standard deviation. Now look at the correlation coefficient. Out of all, only hero is looking like it is independent of a origin as well as independent of a scale. Both it is. And regression coefficient is an independent of a origin like dispersion only, which is a range, a mean deviation, standard deviation, and dependent of a scale like a dispersion. So Measures of central tendency is an independent of origin and scale. Sorry, dependent of origin and scale. Whereas dispersion, that is range, mean deviation, standard deviation, is independent of origin and dependent of the scale. Even regression coefficient also. Correlation coefficient alone is an independent of the both. So important note is that only correlation is the only measure which is independent of both origin as well as the scale. Am I clear? Can I move ahead towards the question solving? Can you please give me the answer for this question? Fadafat. Summary table. How is the summary table? So option C is the correct answer because they are asking about the false statement. False statement means both correlation regressions have a same sign. Absolutely correct. And correlate arithmetic mean of a regression coefficient is always more than. That's what just now discussed. Regression coefficient is independent of both origin and scale. This is correlation, not a regression. Wrong. Correlation coefficient is the square root of the two regression coefficient. It is correct only. If two regression lines are as under, y is equal to a plus bx and x is equal to c plus dy, then what are the variables of x and y is called? So what is the correlation between the correlation coefficient between the x and y? Working really hard. Huh? I am expecting JRF. That is why I want the JRF of all. At any case, I want it. That is what hardly I am expecting. D is the correct answer under root of B and D. Because why B and D? Independent variable. Look at geometric mean of a two regression coefficients are equal to bxy into byx. That is under root of b into d only. That is under root of b into d only. This is bxy and byx. Option D. If regression coefficient of x on y is greater than the 1 and regression coefficient of y on x is less than 1, then geometric mean between the two regression coefficient is a coefficient of correlation. On the basis of above, choose the appropriate answer. What is the correct? Super question. Exclude me. Okay. When the others are going in one direction, you will go in other direction. No? So, okay, no problem. Both are correct. Why? This is a property. This is also property. Just now discussed. Just check back and go back. You will get it. Regression of the x on y, then the variable of y is known as. The regression of x line is x on y, then the y is known as. Independent variable, dependent variable, none of the above, all of the above. This is an independent variable because b x on y means y is an independent variable, x is an dependent variable. Okay. Next, if the regression x on y, y is known as. Acha, question repeated. Huh? No. Same question got asked in the PYQ. That is why. Not repeated. Regression line is x on y, then y variable is known as. Options are different by. Question is same. Option A. Okay, very good. Everybody under the trap? Option D is the correct answer. Option D is the correct answer because it is independent variable is also known as explanatory, which is trying to explain the reason, that is a cause, and that is also called as a regressor. That is also called as a regressor. If R is equal to 1, angle between the two regression line is. Acha, I forgot to explain this point by. Okay. Anyway, I will add it now. You answer this question. If there is a perfect positive or perfect negative correlation, that is R equal to 1 is given. Then how it is? What will be the degree? Is it a 90 degree or 45 degree or 180 degree or 0 degree? It will be a 0 degree. That is what we call it as an coincide. There is a one property which I need to add it. Wait by. There is a one property which I add it over here in the property slide. Eighth property. In case of correlation, in case of perfect correlation, either it is a perfect positive correlation or perfect negative correlation, then two regression lines will be coincide. That is equal to 0 degree. It will be lying on the same line. 0 degree. R equal to 1, or it is a perfect positive correlation or perfect negative correlation is then 0 degree, right? That's it. Good evening, Shivanshi. Too early, Shivanshi. Very good, nice, excellent. Next question, regression coefficient is independent of change of scale, origin, and both scale and origin neither scale. This is a 2020 question, I believe. ये कब start हुआ? Morning start हुआ till the evening 7:30 AM. I am teaching live only statistics. Where you are sleeping? The regression coefficient is independent of the change of scale, change of origin, both scale and origin, neither scale nor origin. Option B is the correct answer. B is the correct answer, that is, its origin only, not of scale.